All right, number 20 is a question about interval of convergence. We should recognize that a ratio test is needed. So I'm going to do the limit as n approaches infinity of the n plus 1th term, and that's going to look like x minus 2 raised to the n plus 1 over n plus 1 times 3 to the n plus 1. And I'm going to divide that, but I'm going to change it to multiplication. Dividing by this is going to be multiplying by the reciprocal. So here's the expression that I get for that. And I want to simplify this and figure out the values for which this ratio converges. X minus 2 to the n plus 1 over x minus 2 to the n is simply x minus 2. N over n plus 1 is simply n over n plus 1. There's no simplifying that I can do there. And 3 to the n over 3 to the n plus 1 is actually a third. So this is what I get on the inside of the absolute value. When I take the limit as n goes to infinity, this part goes to 0. And so x minus 2 over 3 is the answer to my limit. And I know that the absolute value of that, if the absolute value of that is less than 1, then I have convergence. That means that negative 1 must be less than x minus 2 over 3, which must be less than 1. X minus 2 must be between negative 3 and positive 3, and x must be between negative 1 and 5. So that's my interval of convergence. Remember that in these problems you also have to test the endpoints. So I'm going to investigate x equals negative 1 first. If I plug negative 1 back into the original series, I get negative 3 to the n over n times 3 to the n. And if you simplify that a bit, these have the same exponent, so you can divide the bases. So you have negative 1 to the n over n. And we should recognize that as the alternating harmonic series. If you don't, write a couple terms out, but it's negative 1 over 1, plus 1 over 2, minus 1 over 3, plus dot, 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 dot. And so the alternating series test tells us this converges. All right, that means down here on my answer that I'm going to include negative 1 in my answer. And my last step is to investigate x equals 5. When I plug x equals 5 into that, you're going to have a series that goes 3 to the n over n, 3 to the n. These end up canceling and you get 1 over n. And that's the same series as above, except it doesn't alternate. 1/3, 1/2, 1/3, 1/4, etc. And that's a p-series that diverges. So a lot of work for that problem, but I have an interval convergence that includes negative 1, does not include 5. Looks like E is my best answer for 20. 22, a lot simpler problem than the last one. We're given a function. It's defined by an integral. The question is, when does g have a maximum? So g having a maximum, it requires us to look at g prime. You should remember for functions of this type that the derivative is simply the f inside the integral. And so I really want to do a sign analysis of g prime, which is the same thing as a sign analysis of f. The critical numbers are a, c, and d. The derivative of g, which is the graph of f, goes from positive to 0 to negative, and that makes c a maximum. So our answer is C.